Hello, my name is Eyuel Berhanu, and my project is the effect of 3D printing material on 3D print strength. So to start off, a little background. What is 3D printing? Well, 3D printing is the process of adding materials and layers in order to form a complete 3D shape as shown in the little animation. This also gives 3D printing its other name, additive manufacturing, because it adds layers to manufacture a product. So why did I choose this idea? Well, I chose this idea because of my continued fascination with engineering and material science. In my middle school tech ed class, we had access to many different machines, including laser cutters, CNC mills, and 3D printers. But 3D printers always caught my attention, so I ended up getting my own 3D printer for personal use. Once I realized that my first idea for an experiment was a little dangerous and probably wouldn't be safe during a pandemic, I thought to take advantage of the fact that I had a 3D printer and do an experiment involving it. This experiment is also useful to me, and now that I know what material to use in what situations and why it's better to use it in a certain situation. The purpose of this experiment was to test the effect of material, PLA, PETG, and ABS, on their strength. The independent variable, 3D printing material, as shown in the PLA, the dependent variable was 3D print strength, and the constants were test sample design, as shown in the picture, infill percentage, or how much of the test sample was filled, perimeters, or how many times the printer went around the perimeter of the test sample, and testing procedure. My hypothesis was that if 3D printed materials are tested for strength, then rather than PLA and PETG, ABS would be the stronger material. So, the way I set up my testing rig was I started off by embedding two posts into the ground. In between these two posts, I put a cable. Attached to this cable was the test sample, the scale, and the winch and battery, which were used to pull the test sample until it broke, and the scale would measure how much force it took to do that. I had some struggles designing the test pieces to be easy to print, but still be able to print them quickly. I now realize that there are probably more standardized and optimized ways to test the tensile strength of a material. In the future, I would probably find a more standardized design and use that instead. These are the results of each of the three materials, PLA being in blue, PETG in red, and ABS in tan. These were the average load that each material was able to withstand. These were the average loads that each material was able to withstand in newtons, as well as the standard deviation and range, also in newtons. An ANOVA test was performed to determine the statistical significance of this experiment. The p-value was 0.0002, which is less than the 0.05 needed to signify statistical significance. The null hypothesis was if 3D printing materials are tested for strength, then there will be no difference. Through this experiment, I was able to reject that hypothesis. So why was ABS stronger? Well, one of the reasons why ABS might have been stronger is because of the butadiene component of ABS. Butadiene is a chemical that's in the ABS that allows it to have more tensile strength than PLA and PETG, which both don't have butadiene. Another reason why ABS might have been stronger is because of the uses of PLA. PLA is generally not used for structural integrity and is used in more aesthetic cases, while ABS is used in more structural cases and was one of the first materials to start being used by the 3D printing community. But now, as the 3D printing community evolves, a new material is coming out as sort of a middle ground in between the use cases of PLA and ABS. This material is PETG. PETG is a sort of middle ground because it has the aesthetics and printability of PLA, but it also has the strength of ABS, which makes it a good compromise in between the two use cases. To summarize, ABS was the strongest material and my hypothesis was accepted. One point that further agrees with my conclusion is the fact that PLA was unable to withstand more than 100 newtons. It maxed out at 91.7 newtons and never made it above 100 newtons, which both PETG and ABS were able to do. One point that might disagree with my conclusion was the variation of strength in ABS, and its strength ranging between 91.7 newtons and 239.1 newtons, which might have been due to errors. Speaking of errors, here were some errors that occurred during my experiment. Internal stresses due to temperature changes, warping problems with ABS, scale failing during testing. Well, the first problem, internal stresses due to temperature changes, happened because of the temperature on testing day. On testing day, it was significantly colder than the temperature at which the pieces were printed and the temperature at which the pieces were stored, and suddenly moving into this colder temperature might have caused the pieces to contract and introduce some internal stresses which might have caused premature failure. One of the other problems was warping problems with ABS. ABS has a tendency to warp or lift off the bed when introduced into slightly colder temperatures and during printing. This causes the piece to lift up and get thinner in some places, which causes inconsistencies and might have led to that large data range that was seen in the results. The last problem was the scale failing during testing. Halfway through the experiment in one of the trials, the scale was pulled back violently during a violent failure of a test sample. It was pulled into a post, and it dislodged one of its components. A soldering iron was available on hand and was used to fix the scale and continue the experiment. However, this might have caused inconsistencies in later trials. These problems could be solved by doing three things: controlling the temperature of the testing environment to reduce internal stresses during testing, controlling the temperature of the printing environment to reduce warping problems, and adding protection to the scale and post to prevent scale failure during testing. Here were some sources that were particularly useful during my research and allowed me to understand the properties of each of these three filaments and allowed me to make an informed hypothesis. Thank you for listening to my presentation. I will now take questions.